Welcome to The Explainer. We're all about breaking down big topics into clear, visual stories. So today we're jumping into the fascinating biology of how twins are made, and it's a tale where just a few days can change absolutely everything. Okay, so you've probably heard the terms identical and fraternal your whole life, right? But the difference between them goes way beyond just looking alike. It actually comes down to two completely different biological events that happen right at the very start. So what's the real story here? Well, the whole secret lies in this tiny, super critical window of time. We're talking the first 14 days after fertilization. You know, the things that unfold right here in these 2 weeks, they set the stage for two totally different twin journeys. All right, let's dive in. To really get our heads around twins, we've got to go all the way back to the beginning, to the moment of conception, where the path almost immediately forks into two very distinct possibilities. So every single twin pregnancy kicks off by going down one of these two roads. The first one is called dizygotic, which just means two zygotes. And that's what gives us fraternal twins. The second path is monozygotic, or one zygote, which, you guessed it, results in identical twins. The huge deciding factor? It's all about how many eggs get fertilized. Let's start with the path that's way more common. Something like 70 to 80% of all twins are fraternal, which means they come from a dizygotic pregnancy. So here's what happens. Two separate eggs get released, and they're fertilized by two different sperm. Really, it's just like having two siblings who happen to be conceived and born at the same time. And because they start out as two totally separate zygotes, they're only about 50% genetically similar, just like any brother and sister. That's why they can be different genders. Now, the big thing to remember here is that since they start as two separate little bundles, they always build their own separate life support systems. That means their own placenta and their own amniotic sac. Think of it like two completely separate pregnancies just happening to share the same space at the same time. Now, for that other 20 to 30%, this is where things get really interesting. The monozygotic path starts with just one egg and one sperm, but then something remarkable happens. It splits. So it all comes down to this one crucial idea. For identical twins, it's not if the single embryo splits, it's when it splits. The exact timing of this division in those first couple of weeks literally determines the entire architecture of the pregnancy. Okay, so if the split happens super early, let's say between days 1 and 3, each little embryo has enough time to go off and develop its own placenta and its own amniotic sac. This is what's known as dichorionic/diamniotic. Di just means two, so it literally translates to two placentas and two sacs. Doctors call them DCDA twins for short, and from the outside, they look just like fraternal twins. But what if that split happens a little later, maybe between days 4 and 8? Well, by then the structure that's going to form the placenta has already been established. So what's the result? The twins will end up sharing a single placenta, but they'll still have their own separate amniotic sacs to float around in. This is actually the most common type of identical twin pregnancy. Now, if the split gets delayed even further to somewhere between days 8 and 13, both the placenta and the amniotic sac have already formed. In this case, the twins are going to share everything. These are called monochorionic/monoamniotic twins. Mono meaning one, so one placenta and one sac. They're much rarer and, as you can imagine, face the highest risks. And finally, if the split happens after day 13, the embryonic disc is already fully formed, and that means the division can't complete itself. This incredibly rare event is what results in conjoined twins, who remain physically connected. So why are we so obsessed with this timing? Why does it matter so much? Because, as we've just seen, how much infrastructure the twins share, the placentas and the sacs, is decided entirely by when that split happened. And sharing those resources, especially the placenta, comes with some pretty significant risks. Here's a really simple way to think about it, using a house analogy. The chorion, which forms the placenta, is the house. And the amnion, the sac, is the room. So twins can either live in two separate houses, or they can share a house but have their own rooms, or in the rarest cases, they have to share both the house and the room. And what's really amazing is when you see it laid out like this, you can so clearly see the link between sharing and risk. DCDA twins, with their own separate houses, are the lowest risk. The MCDA twins, who share a house, are at a higher risk. And the MCMA twins, sharing both a house and a room, well, they face the highest level of risk by far. So what exactly are we talking about risk-wise? Well, when a placenta is shared, you can get these abnormal blood vessel connections between the twins. This can lead to something called twin-to-twin transfusion syndrome, where one twin gets way too much blood and the other gets way too little. And then, when an amniotic sac is also shared, you have a really serious risk of the umbilical cords getting tangled up with each other.